All right, guys. Everybody have a note sheet? Yes. All right, guys. Any questions over the homework before we get started?
Why?
Why? What we're looking at today is more factoring. A lot of the ones we'll look at today are kind of special types of factors or factoring. They look a little bit different. Now the first one we're looking at is this one here. 4x squared minus 4x plus 1. Now for the most part with these first three, they're not going to be any different than what we did previously for the last two sets of notes. It's just we're able to condense it a little bit at the end. Now, since there is not a greatest common factor between these three terms, we'll move on to our two sets of parentheses with three spaces. If it was 4x squared minus 4x plus 4, then yes, we could factor the 4x. Then it would, but since the last one's 1, we don't have a greatest common factor. Now, since the third term is positive, the signs are the same and match the sign of the middle term. So we'll have minus and minus. Now, the factors of the first term, 4x squared, well, we'll have x and x. So we'd either have 1 and 4 or 2 and 2. Which one do we want to try first? We'll do 2 and 2. Factors of the third term, 1 is, well, 1 and 1. Now at this point here we can check and make sure we do have the correct factors. 2x times negative 1 is going to be negative 2x. Negative 1 times 2x is also negative 2x. And negative 2x minus 2x would give us negative 4x. Is that the middle term we want? Yeah. So our final answer for this here is 2x minus 1 times 2x minus 1. Now what's interesting is because since this is the exact same term twice, we could actually condense it down to 2x minus 1 squared. Because whenever we square something, we're just multiplying it by itself. So we could write it out as 2x minus 1 times 2x minus 1.
We are now ready for the senior boys to come to the office. Senior boys to come to the office.
And leave it there, or we can condense it down to 2x minus 1 squared. Questions on this here? All right, let's look at the next one. 16b squared minus 40b plus 25. And if we look at this here, 16, the numbers that can go into 16 are 1, 2, 4, 8, and 16. But none of those are factors of 25. So there is no greatest common factor for this one here. So we'll move on to our second step, which is our two sets of parentheses with three spaces. Now we're going to find the sign. The third term for this is, so the signs are the same. Match the sign of the middle term, so we have minus and minus. Now we want to find the factors of 16b squared. Well, the b squared will be b and b. So for the factors of 16, we have 1 and 16, 2 and 8, 4 and 4. 2 and 8. And we also need to find the factors of the third term, factors of our 25. And 25, 4, 5, and 5. Which one do we want to try first? 5 and 5. And we can check this here. 2b times negative 5 is going to be negative 10b. And negative 5 times 8b is going to be negative 40b. negative 10b minus 40b is going to be negative 50b. We can. We can try 4 and 4 instead of 2 and 8 with our b. And we can try this again. 4b times negative 5 is going to be negative 20b. Negative 5 times 4b is negative 20b. Yes. And since these are the exact same expression, guys, let's focus in. We can simplify it to negative or 4b minus 5 squared. Because whenever we have the same term, the exact same set of parentheses, we can condense it down into one being squared. Questions on this here? Because really these factors are called perfect square trinomials, or the original one, because we can rewrite it as a single set of parentheses being squared. Let's look at one more of these. Let's look at this one here. 100x squared plus 180x plus 81.
Nothing goes into it because that 81
Almost. Not an 81. Let's change. I'm going to add one little thing to this. Let's put y and y squared. Interestingly enough, it's not going to actually change that much. Because there is no greatest common factor. So move on to our two sets of parentheses with 3 spaces. The third term for this here is 81, and it is positive. So the signs are the same and match the sign of the middle term, which is also positive, plus and plus. Now the first thing we're going to look at is the factors of 100x squared. Well, the x squared is going to be x and x. And the y squared would indeed be y and y. So even though we do have x squared and y squared, x and x, y and y. And this especially works, or the main way this works is when the middle term is xy, because it's going to have both. Now, any other questions on how the y came in or affects this? Yes, sir. Questions on x, y, signs? Okay. Now, factors of 100 are 1 and 100, 2 and 50. 3 is not a factor, but 4 and 25. 5 and 20. 6. And then 10 and 10. Which set of factors for 100 do we want to try first? Four and 25. Factors of 81. We have 1 and 81. 3 and 27. 4 doesn't work. 5 doesn't work. 6 doesn't work. 9 and 9. Which set of factors for 81 do we want to try first? 9 and 9. All right, let's check this here. Now our 4x times 9y is going to be 36xy. 9 times 25 xy, which is going to give us 261 xy. Is that the middle term we wanted? Yes, we could switch the 4x and 25x to 5 and 20. Yeah. 5x times 9y is going to be 45xy. 9y times 20x is going to be 180xy, which will give us 225. So 10x times 9y is going to be 90xy. 9y times 10x is going to be plus 90xy, which does give us our 180xy. So 10x plus 9y times 10x plus 9y, or we could say that it's 10x plus 9y squared. Questions on this here? N squared minus 25. Now these should look familiar. These, I think, are some of the ones that we like a little bit more than the others, because these here are our difference of perfect squares. Because if we have two squared terms, two perfect squares being subtracted, they will always factor in the form of this here, because a squared minus b squared is equal to our a plus b times a minus b. We just need to find out what a and b are for this here. So what times itself is n squared? Or 1n, because n times n is n squared. What times itself is n squared? Well, that would just be n. Now what times itself is 25? 5. So if we're comparing it to the general form, a is n, b is 5. So it would tell us that this here factors to a plus b. So n plus 5 times n minus 5. Questions on this here? Are you ready for the next one? 16n squared minus 9. Again, we have two terms being subtracted, so there's a good chance it's a difference of perfect squares. So what times itself is 16n squared? Well, that'd be 4n. And what times itself is 9 would be 3. So this here would factor to what? 4n plus 3 times 4n minus 3. Questions on this here?
What was the
So a squared minus b squared is equal to a plus b times a minus b. So we just need to find out what is our first term squared. So what times itself gives us our first term, what times itself gives us our second term. So for here, 4n squared, 4n times 4n would give us our 16n squared, and our 3 times 3 would give us our 9. So 4n plus 3 times 4n minus 3. So let's look at this next one here, 4m squared minus 25. Because 2m times 2m squared is our 4m squared. And 5 times 5, or 5 squared, gives us our 25. So that means this factors to 2m plus 5 times 2m minus 5. Now, since they are different expressions, one's plus, one's minus, we can't condense it to a single set of parentheses being squared. Questions on this here? Now, this here is, so what times itself is a to the fourth? Because a squared times a squared, when we multiply like bases, we add the exponents, which would give us a to the fourth. And what times itself is 9? 3.
A squared squared.
A squared squared, yep. Powers of powers multiply. Now the reason I show this is it works out the same as if we were still doing our difference of perfect squares. And when we factor this, well, we'd have a squared plus 3 times a squared minus 3. Yes. Now again, we need to make sure that this is factored completely, because whenever we still have that square, that power of 2, or a power greater than 1, we need to make sure we can't factor it further, because here a squared minus 3, a squared is a perfect square still, but 3 is not. So that's as far as this goes. Questions on this here? We ready for the next one?
And there's no perfect square for 6, so you keep it this.
Mm-hmm.
K squared minus 6, K squared minus 6.
Yes. Questions on how we got to this point here? A squared minus 6 does not factor any further from there. And there is no sum of perfect squares. Sum of the two squares formula is just, we do not have one. So this is as far as this will go.
This is really just looks like simplifying.
A little bit, it is kind of like simplifying, and especially our difference of perfect squares has such a nice formula and method for it, it works out nicely. And especially if we do have two terms being squared, two terms being subtracted, and we can't find what multiplies by itself, check for a greatest common factor. Because there could be a greatest common factor we have to pull out first, and then it would become a difference of perfect squares. All right. Yes. So we'll start here. So what times itself is x to the fourth? Well, that would just be x squared, because x squared times x squared. All right, guys. Will give us x to the fourth. And what times itself is 81 is 9. Yes. So, questions on how we got to this point here? Huh? Yes. Any questions on how we got to this point here? Now, as it's been mentioned already, x squared plus 9 does not simplify. We don't have a difference of, or a sum of two squares. But if we look at this second one, x squared is a perfect square, kind of as we've had so far. 9 is a perfect square, because it is 3 times 3, which means the x squared plus 9 stays there. But we can factor the x squared minus 9 to be what? X minus 3 and x plus 3. Because the x squared minus 9 will actually factor once more. Because with the x squared minus 9, we can have it as x squared minus 3 squared. Difference of perfect squares still.
think that we do the same thing.
Unfortunately, we can't do it with the plus because there is no sum of two squares. I mean, technically it is possible to factor it, but its factors are imaginary terms.
I think my brain started
Oh, mine's been like that for a long time.
Yeah, I know.
Yeah,
Like that.
because we need that middle term to cancel, and the only way that the middle term will cancel is if the signs are different, which means the third term has to be negative. Questions on this here? Questions on anything we've done so far?
I went from
Now, even with any of these here, I'm going to add this. Let's just say 16 a squared minus. So guys, let's look at this one here. Sixteen a squared. What times itself? It'd be 4a squared. 17b squared would be 7b. So this would be 4a plus
Maybe
7b.
before her, the girl I was talking to, cheated on you.
All right, guys, focus in. So even if we do have a and b squared, two different variables, this still works out the same. Same type method, same type form to factor these here. I just added this in. Questions on any of this here so far? Now the next formula that we have are these here.
You always say something. Yeah, I'm a good person. That's very debatable. Give me like 2 hours to gather something.
So, all right, guys, let's focus in here. Now, this is new. Sum and difference of two cubes. Sum and difference of two cubes has a specific pattern to it. And there's a few specific steps that we're going to follow to find it. The first is finding out what times itself 3 times gives us our two terms. We're really finding the cubed root of our first two terms. So we're really finding the values of a and b. The first main step is going to be to find the values of a and b. Not so much their cube, but just what number times itself 3 times gives us those two there. Then we're going to set up our factors. Because the first set of parentheses is going to have 3. The second is going to have 5. First, we have one sign and 2 terms. The second, we're going to have 2 terms, or 3 terms and 2 sets of signs. Third step is going to be our signs. And our signs are going to be the same, opposite, always end on a positive note. Same, opposite, always end on a positive note. because even with our plus, if we look at this here, so start out as plus, so same, opposite, always end on a positive note. The signs are going to be the same, opposite, always end on a positive note. So we start off with minus, so same, opposite, always end on a positive note.
That last one's 5.
5 ones, yep. So we'll have 3 terms and 2 signs. And the last step is going to be to plug in values for A and B. Plug in the values for A and B.
Not what?
Positive note. Yep. Always end on a positive note. Same, opposite, always end on a positive note. Yep. And there's a specific way the values, especially in the bigger set of parentheses, go, and we'll see that here in a second. X cubed plus 125. So we need to find A and B. What times itself 3 times is x cubed. And what times itself 3 times is 125. Well, the x cubed is kind of nice because that's just x. Now we need to figure out what times itself 3 times is 125. Well, to do that, we're going to take the cubed root, because the square root tells us what times itself is that number. Cubed root tells us what times itself 3 times. So 5 times 5 times 5 is 125. So the cubed root of 125 is 5. So our A in the general form is x, B is 5. So that is telling us that this is a difference or a sum of 2 cubes. All right, guys, focus in, focus in. Now we're going to set up our parentheses. The first one's going to have 3 spaces. The second one's going to have 5. Questions on this so far? The signs are going to be the same. Opposite always end on a positive note. So since our starting was plus, so our first sign to be the same as plus. Opposite, so we flip it to minus. Always end on a positive note. Now we're going to start plugging in our A and B. We'll start with A. In our smaller set of parentheses, A just goes in the first spot. B goes in the second. Because that first set of parentheses is either going to be A plus B or A minus B. We stick our A and B in there. Questions on this so far? In the bigger set of parentheses, we're going to start off with our A term. It's going to go first, and it is to the second power. Because in the bigger one, we're looking at a quadratic. And that first term, that A term, is going to go squared in the first spot. In the middle, it is really to the first. And in the last spot, and this is going to be the only time we really write this, is going to be to the 0 power. Because that power or exponent with A is going to 1, 0. It's decreasing. Questions on our A term and how we plugged it in with x. Now the B term is 5. Now in the first spot, even though it's not written, it's really to the 0. And it's going to go up. In the middle, it's going to be to the first. And the last one, it's going to be squared. But the x to the 0, 5 to the 0, this is going to be the last time we actually write it. Because anything to the 0 power is 1. Because 5 to the 0 is 1. So really what we're saying here in the first spot is that we have x squared times 1, which is just going to be x squared. Minus, in the middle, we have x to the first times 5 to the first, really just x times 5, which is 5x, plus, again, x to the 0 is 1. Now, we do need to simplify 5 squared. 5 squared is 25. So the factored form of x cubed plus 125 is x plus 5 times x squared minus 5x plus 25. Now, the bigger the quadratic part of a sum or difference of perfect cubes is not going to be factorable. It will not factor. Questions on this here? We'll stop there for today.